So we've already been using the normal force in a number of examples, but I want to clearly establish what are the rules for working with the normal force. And the main rule is that the normal force is always perpendicular to a surface. Another thing that's maybe worth noting is that the normal force doesn't really have a formula for it, but in problems where you need to know what its magnitude is, that's going to have to come up in the analysis somewhere if you want to find it. So looking at that first rule, though, I've got kind of two examples I've sketched out really quickly here of a box sitting on a level surface and maybe a box sitting on an incline. And we've looked at some boxes before, I think, on an incline, but it's maybe worth recapitulating really quickly here that the way the free body diagrams would look for each of these is for this first one, gravity points down, and in this case, because the surface is level, the normal force can point straight up. For this second one, gravity will still point down, but because the normal force must always be perpendicular to the surface, it's going to have to be at some angle here, which means for this thing to be in equilibrium, there'd probably need to be a friction force here, or if there isn't one, it actually would mean that this object is accelerating down the incline because of the lack of friction. So either one of those is a possibility, but either way, the normal force has to be oriented so that it's perpendicular or at right angles to the incline that the box is on.